very much my pleasure to introduce to you from Mega, Mr. Matthias.
Thank you. Okay, welcome everybody. The topic that I will talk about today, which is the design decisions that we made around making cryptography more accessible, is one that you need to lose any sleep over, yet I see that a number of you did. And as I will also go into the wider topic of code trust and trust in computing environments, which is slightly more interesting than just focusing on JavaScript. So, as you may or may not know, Mega is a cloud storage company. It is offering end-to-end encrypted cloud storage, and as a specialty, it does so within your web browser. There's a number of companies that do offer end-to-end encrypted cloud storage, but none of them actually does it in the browser. Of course, there's also a C++ SDK available for integration in native apps, so it's not just purely browser-based access. And we currently have 5.5 million users storing about 12 petabytes of data, but that's a number that changes rather quickly. So end-to-end encryption is pretty much essential if you want to have secure cloud storage. It's basically ideal for cloud storage. The user provides the master crypto key, and no usable keys or plain text is ever residing anywhere outside the communication endpoint, and the communication endpoint is always deemed secure. That's a necessary precondition. It might not always be true, but it is assumed to be true. And the fact that server-side encryption is not an option is illustrated by a little issue that Dropbox had in 2011, where after a software update, their authentication checking broke, and for about 5 hours, you could log into any Dropbox account with any password. And the result was, of course, a full breach, or theoretical breach, of all stored data on Dropbox, which would not have happened had they used end-to-end encryption. And another topic that is becoming an issue is the fact that governments are getting very interested in stored data residing on cloud storage providers. And it's very easy for a government to just retrieve and snoop all files stored in Dropbox. So that's another reason why end-to-end encryption is pretty much essential these days. So the key difference between end-to-end encryption and server-side encryption is, of course, that end-to-end encryption results in no breach of data when the account is breached. So even if you would be able to log into an account of a cloud storage provider with end-to-end encryption, you wouldn't see anything useful. And with server-side encryption, there's no such thing. You can always just go into anyone's files. If you want to compromise an account of an end-to-end encrypted cloud storage provider, you would have to send malicious code to the client, which is, in theory, always detectable. Whether it is happening in practice is another matter, but in theory you could not do so without the user being able to detect it, and that's quite an important fact. As we all know, encryption must be easy to use or it will not be used. Unfortunate example is PGP, which after 22 years has still not really gone mainstream outside the tech community, and therefore it's essential to lower the barrier to entry. And one of the, or pretty much the only way to do so is to move cryptography to the browser so that you can just open the URL of the cloud storage provider and use it without any installs or any hassle up front that would result in probably the majority of users not using it. Nevertheless, for some reason, the choice of using JavaScript to do crypto has stirred up quite a lot of emotions, and I'm just quoting 3 significant allegations. JavaScript is a terrible idea, someone said. Then someone said, well, we do cryptography in JavaScript, that's bad. We use RC4, that's bad. Just on a side note, we use RC4 for static content that is public. We tried to use the null cipher, but it didn't work. There's no security implications by by using RC4 in this particular context. Of course, for the more sensitive communication, the API communication, we don't use RC4. And then someone said that generating random numbers in JavaScript is so bad that you would rather fetch them from random.org. So these 3 quotes illustrate what a emotionally charged topic crypto in JavaScript is, and that's the reason why I would like to address this issue today. And we looked at a number of alternatives. You could, of course, use Java applets, but with the recent security issues after the Oracle takeover, I would not advise anyone to run a Java virtual machine in their browser. Flash has even more security holes and is by a factor of about 10 or 20 slower than today's JavaScript. So Silverlight is dead, and ActiveX I think you don't really want to use on a cross-platform environment either. So JavaScript on current browsers is of course sufficiently Turing complete. It now features a cryptographically strong pseudo-random number generator. I haven't audited the code of that, but I assume that it's good enough, but still we enhance it by user-provided entropy. Very important, it's able to read local files, and it can even write local files, but it requires a bit of hacking on most browsers. It's not fast, but it's fast enough, and with the upcoming enhancements like web crypto and ASM.js, we will be looking at satisfactory performance. But even today, you can easily encrypt like 30 megabytes a second AES in JavaScript. The development of performance of the various platforms is quite interesting. Flash got marginally faster. JavaScript in IE just started to beat Flash in 2011. However, today it's actually quite fast, so this graph is not quite up to date. In Safari, little hope. Opera, with Opera Next, this is also obsolete, of course. Firefox is already pretty good, and Chrome really drove the development in that regard. The V8 engine is really basically bringing JavaScript performance to a level where we can actually use it. Today, IE is actually, IE 10 and 11 are actually almost as fast as Chrome, and Firefox is also quite performant. And the expected performance boost in the crypto context makes this even less of an issue. So the question is, it's fast, you can do it, but is it secure? Is it desirable to do crypto in JavaScript? And when you look at the comparison between JavaScript and native code, it's actually quite interesting. If you have rogue code, you would rather be running JavaScript than native code, because rogue code in a browser can do very little other than ruining the specific domain and the security of that specific application. While native code, if you don't run it in a sandbox, can ruin your entire account or even system if you run it as administrator. If you have buggy code, then the risk to host is, again, very low if you run JavaScript, but it's low to potentially high. For example, if you have a buffer overflow that's being exploited in a tool that you use, then again, your entire machine could be, or at least your account could be jeopardized. However, if you have a compromised host, JavaScript and native code are equally completely compromised, because of course you can interfere with the operations of JavaScript when the machine is breached, and you can interfere with the operation of native code when the machine is breached. And it makes no difference whether you inflict the compromise intentionally yourself or you install some Trojan that you downloaded from the wrong source. Are current web browsers a good runtime environment? Not really. We have a long history of browser implementation bugs. Unfortunately, many of these allow JavaScript to break out and execute code on the machine itself, which means that JavaScript sandboxing did not really work. And we have a lot of same origin policy breaches as well, so one site could interfere with another site data. Then very interesting and relevant topic is cross-site scripting, where the user supplies content and the content then gets interpreted as code. Fortunately, browser vendors introduced a mechanism called content security policy. If you have your application properly separated between code and content, and you activate the appropriate content security policy, you will not run a great risk of suffering cross-site scripting exploits. And JavaScript also provides a better separation between unrelated apps unless the browser is buggy, than a native code if you don't run it as in virtual machines or in different user accounts. The crosstalk and timing attacks on parallel running applications running in parallel is more of a theoretical issue, so I have not seen any working exploits for that. And the more advanced APIs that are interesting for crypto are missing from JavaScript. That's a bit of a disadvantage. For example, if you're concerned about your keys ending up in your paging files, then you might not want to use JavaScript because there's no API to lock screens in memory. But again, if you hibernate or if you suspend to disk, then even those locked pages, of course, make it to your hard drive, and that's then no big difference. The biggest issue with JavaScript is actually, and not only with JavaScript, is code delivery. Can you actually trust the code that you're about to run? With native code, we have on Windows and Mac OS and other commercial platforms built-in cryptographic integrity check. It's called code signing, and you can obtain commercial certificates from vendors that also offer SSL certificates. And that's a big weakness because, of course, commercial vendors are potentially subject to national security letters, and they might cooperate supplying forged certificates that make the code look like it's yours, but in reality it's not. On open platforms, you usually install your software from independently cryptographically signed repositories, which I don't know how resilient, for example, Red Hat would be to a request from the US government to put some stuff into their repositories. Or better, compiled from source code, and when you compile from source code, you would then have a hash that is hopefully published through an independent channel that you hopefully verify manually. Also, native code is installed once and then run, while JavaScript, unfortunately, is not integrity checked, and it gets loaded and refreshed upon every time you load the website. So there's many more opportunities, although the initial install pretty much suffers from similar trust issues. There's many more opportunities for a website operator to plant Trojan JavaScript on a client machine than of a provider of native code that just goes into installation once and is possibly installed with a separate verified hash. We have cryptographically signed updates in native code apps becoming more popular. That's a benefit because the key resides with the original programmers, but could also be a risk because, of course, those programs, especially if they're located in the United States, might be subject to legal action. So, in conclusion, if you want to deliver malicious code, especially if you want to deliver it specific to a target, you're better off with JavaScript. So here we have a significant disadvantage using JavaScript. And there is a mitigation mechanism. You can install browser extensions that still don't have full access to the machine, but they are then holding the JavaScript locally, so you don't have to reload it from the server every time you visit the site. And you can cryptographically sign the updates. So this brings it back to the cryptographically signed auto-update scenario of native code. And that's what we offer as an option. If you want to inject malicious code, there are various vectors or sources. You can do so by or through the legitimate source. So if the original programmer decides to go rogue or is forced to go rogue, then that's the point where you can always inject malicious code. You can just hack or physically compromise the web server that is hosting the JavaScript or the binary. You can use a network man-in-the-middle attack for HTTPS, which everybody should be using today. You need to, again, forge a certificate, which should be easy for governments. And on top of that, you need to breach the network connection somewhere between the user and the server, and or the name server, which should also be possible for governments. If you want to manipulate JavaScript, it's easy. Unfortunately, there's no mechanisms offered by browsers that would hash JavaScript and reject suspicious, or allow the user to reject suspicious changes. And if you want to manipulate native code, as I said before, commercially signed native code requires a forged certificate, and then, of course, needs to be placed on the appropriate sources. And if you have a separate published and manually verified hash, then you are quite secure if the separate channel is not compromised. but unfortunately you need to then look at the hash and compare it, and that is not happening always. So the problem of code and code trustworthiness in general can be addressed by looking at the code. And unfortunately, if you want to audit, for example, Windows, or even just a single run of Windows update, you would spend a lot of man hours, and therefore it's not really practical. And if you want to hide backdoors, then it's a bit easier in C or C++ than in JavaScript, although if you are a competent programmer, you would probably be able to hide a backdoor in JavaScript as well. I'm just thinking about memory overruns and such things that don't immediately seem apparent to the untrained eye. And unfortunately, it's a fact that most code running today never got subjected to a full and independent audit. So we have to rely on trust. Trust. And that's not such an unusual phenomenon to rely on trust for important things. For example, when we eat, we trust quite a number of people. When we board a plane, again, we blindly trust people that we don't know. If we boot an operating system, we trust a large number of people, or run any kind of non-trivial software. So for example, there's more than 1,000 people working on Windows, there's more than 2,000 people working on Office, there's 2 people working on Mega, or at least the developers, the original developers, now it's a bit more. So is it better to have a lot of people that maybe check each other? We hope that Microsoft uses proper processes to independently verify check-ins into their source trees, but we don't know that. And of course, trusting the 2 Mega people is also questionable given their history. So another issue with trust is that even the most trustworthy service provider or software vendor might be subject to government action that forces them to basically relinquish the good faith that they had and build backdoors into code. Although they didn't actually want to, they might have been forced to. And again, we are back to the fact that auditing code is a pretty much necessary requirement in this undermined trust environment. With binaries, as we have seen, it's really not possible. So in theory, Windows Update is a good vector for the targeted delivery of spyware. We don't know of any case where a commercial software vendor has used the auto-update mechanism to actually Trojan a user upon the request of a government or a law enforcement agency. But it's not really needed because the user is likely to run Flash or Adobe Reader, and there's surely some zero-day available for that. With source codes, it's a bit easier, but still complex. If you want to audit the source code of a non-trivial software project, you would still spend significant time. Mega's JavaScript is open source, it's non-minified, so if you want to have a look at it, do so. And we of course have the bug bounty running, so we incentivize people to look for and find backdoors, and so far none was found, so it either means that nobody was looking or that none is there. In an ideal scenario, the base version of a program is fully audited once, and from there on all updates get audited by a number of independent reviewers. Each reviewer has their signing key, and the browser extension that I talked about only really accepts the update, or even native code would only accept an update if there is a certain threshold met of reviewer signatures. And unfortunately, I don't know of any real-world application of this desirable scenario. And it's also quite a number of man-hours involved into non-trivial updates again. So it's just the work that goes into auditing code that makes it a really difficult issue. As a conclusion, I would say that sandboxed and hashed native code is actually better than JavaScript if accessibility is not a priority. So if you run your binary in a separate sandbox and you don't give it any special privileges, and you hash it, and you look at the hash, and it matches, then the only real attack vector that would go undetected through the lack of auditing is the actual original programmer implementing something bad or being forced to implement something bad. And this is still a very rare case. So this is the preferred mechanism. Unfortunately, it does not really lend itself to usability. If you have to first fire up your sandbox and install a binary and check the hash, it's not the accessibility that a mass product should warrant. JavaScript is better than non-sandbox native code because it provides inherent sandboxing through the browser. Therefore, if you have malicious code, it does not kill your machine. It just kills itself and the security that it claims to provide. So this would be the Mega scenario. Mega could not run code on your machine unless you run a very old browser or some new native code execution. Browser 0-day goes into the wild. JavaScript and native code suffer from similar trust issues. So whether you have the source code of a C++ binary, or if you have JavaScript, you still would have to audit it in theory before running it. So there's no real big difference other than the fact that JavaScript is probably easier to audit, but marginally so. And JavaScript lacks the browser-enforced integrity checking. That's a little bit of a shortcoming. I would love to see browsers offering such a capability natively, either through certificates or at least through some hash that would then be published on separate web channels, or even better, through a broadcast medium that is not really tied to the internet. For example, you could print it in newspapers, and then people would just compare the hash of the day, and if there's a discrepancy, they should be alarmed. But not sure that's going to happen. So overall, the picture is mixed. We see that JavaScript is not as bad as some think it is. It's not perfect, but neither is native code. You can still do a lot of harm to a trusted environment through planting Trojans through native code. Okay, that's the situation. Any questions?
In terms of media, are you storing hashes of the file that's uploaded instead of just...
Yes, we store hashes of the file that's uploaded post-encryption. And the crypto key is randomly generated, so the only files that really have several independent, identical encrypted versions are files of up to 3 bytes in length. There we get collisions. But anything longer than that, it's very unlikely, although it's theoretically possible that the same file is encrypted with the same key if you hack your upload code, or it's possible that coincidentally the same file or different files encrypted with different keys still end up as the same file. But that's unlikely starting with more than 4 bytes of file size.
So unlikely, why are you doing it?
Well, the fact is that short files are usually not very mission critical, and longer files are so unlikely to collide that we simply deemed it sufficient to have that kind of risk. So if you have a 1 kilobyte file, it's 2 to the power of 8,192 is the collision risk. And if you print that number, you will see that it's not going to happen in real life.
Do you code review the code that it's not written by Mega?
We, as I said, have a security bounty or a bug bounty running. So we hope that a lot of competent people would have looked at the code already. We, of course, cross-review, so we look at each other's codes, but we don't have a formal, independent, external review from a commercial vendor. We might actually do that, but we already challenged the community, and they found quite a number of non-malicious issues that were fixed very quickly. And there was no sign of a planted backdoor. And as far as I know, none of our programmers has any intention to do so. And also, although New Zealand has now gotten the new law that requires assistance from service providers, we strongly believe that it does not cover our case, and it does not make it possible for the New Zealand government to force us to plant any backdoors before we actually object to it and possibly move Mega offshore in order to prevent this jurisdiction from interfering with our user security.
That's not what I meant. I meant we code review the third-party software you are using.
Oh, we are not using any third-party. Well, we are using some third-party components that are widely used, and we assume that if there was any security issues in those, that would already have surfaced. But there's indeed an issue there. The comprehensive code review has to include all third-party components, be the SJCL crypto library or jQuery or all these other components that we use. Also, of course, the platform that you run the JavaScript on would, in theory, also have to be subject to auditing. This starts with the BIOS of the computer. This goes on to the operating system, the browser, of course, any other software that's running on the same machine. And for the really paranoid, the CPU and the chipset of the machine should be included, because there have been some conspiracy theories that Intel has some backdoors in their chips, which I think is too low level to be viable, but for example, the built-in random number generator of Intel chips might be weakened artificially. We don't know that.
Would you pay a bounty if the bugs got a third-party library?
No, we don't include the third-party components in our bug bounty, but we hope that the third-party vendors would support the finder. You would probably address it to the third-party vendor directly anyway. But we use very common components, and those should be widely peer-reviewed, so we hope that there is nothing too bad in there.
You mentioned that exploitation of the client-side code should be theoretically detectable. Is that not a little bit at odds with the accessibility goal?
If you have something that warns you if there's a mismatch or if there's an update to the code, and you then, if you are sufficiently paranoid, compare the new hash with a published independent channel, it does interfere with usability. Indeed, there's a certain clash.
That's what I mean. If you've got an average user that's not technically inclined, are they going to be able to have the skills to detect an exploitation?
That's exactly the problem. If you have a user that looks at, for example, diffs between an old and a new version, you could easily display the lines that have changed. The normal user would not really make any sense of it. So it would have to be an independent body that does look at it every time it happens, and then basically through some channel says, yeah, I looked at it, it's good. You can, if you don't trust these guys, you can at least trust me or several different people that have to sign it off. And the ideal scenario that I depicted, where the browser extension only really accepts an update once there's a minimum number of sign-offs by independent auditors, that would implement this ideal scenario in a user-friendly manner. And that would be ideal, but it's not happening at this time. So there is a certain risk, I have to concur.
Theoretically, the government or some other organisation could give you a list of basically shard hashes and ask, say, if you have any matches for these hashes, red list them, maybe let us know. I guess what I'm leading on to, have you received any requests from governments or other organisations for any data inside of Figure?
No, the government would not. Exactly. The government would not be able to ask us, do you have users that have this particular file in their accounts? For example, think of a terrorism video, and they would send it to us and say, look, this file has surfaced on some Al-Qaeda website. Do you have any users that uploaded the same file? We couldn't tell because, of course, it is post-encryption. We only see the file post-encryption, and we would have to know the crypto key that the user happened to use when uploading that file. So we couldn't satisfy
The
that.
hash is the encrypted value rather than the hash.
Correct. We only see the encrypted file. That's very important. We don't ever forward the hash, because that would be client-side security. The client-side would have to credibly forward us the correct hash. There's no way for us to check whether the hash that we get presented by the client-side is actually the real file's hash, so we don't even do it. We see and only take the hash of the encrypted file on our own servers for deduplication purposes. And the fact is that if the government finds a megalink with the key attached, then it's a different story. Then we can, of course, tell the government under a warrant which user uploaded it. But that's different from this wide-scale snooping based on a file's hash.
Sorry, I'm confused. If you see the hashes after encryption, the likelihood of having two hashes the same with files encrypted with different keys.
It's very low. I said 1 kilobyte, 2 to the power of 8,192. So it's quite impossible, I would say. It would probably not happen within the lifetime of the universe.
So you're only saving, making savings with very small files.
Correct. Deduplication does not really have any effect beyond very small files. But it has to be said that if someone imports a file into their account, then there's no physical copy happening on the server or re-encryption happening. So there is the deduplication.
Could they just not ask for the, do you have any files with specific byte length, and then get the users based on the byte length of the file?
Theoretically, yes. So if you have, we know the file size, of course. So if you have a very large file that has a particular size, then yes, it would be possible. However, I don't know if the evidentiary value of the byte length of a file would actually warrant or convince a judge to issue a warrant for a person. We don't know that. Might be. If it's a very long file, multi-gigabyte file, and it has a very odd length, then it might possibly do so. So if you're uploading anything bad, make sure that you pad it.
As far as metadata attacks go, you mentioned that if one user moves it to another user's account, it doesn't change anything.
Correct.
So could I do a search warrant against you guys and say, this person here is a known bad guy, could I have all the accounts of everybody who's...
Yes, yes, absolutely. Don't import bad files into your accounts, please. And if you do so, download them first, pad them, and re-upload them.
So just you keep talking about this padding, so is that next thing you're going to implement? Automatic random padding?
No, we won't do that. We don't know the file's structure and whether it would be adversely affected by padding. Most file archive formats should be resilient to it, but we don't want to end up with destroyed data after downloading. Maybe as an option, but not as a standard. Yeah, could be a user optional, or we could say if it's a .zip file, then do it. Yeah, it's a possible extension.
If you just do XML tags and say, I'm starting padding here, 12 digits, in setting, and then when you download it, you just go,
Right. You could prefix the file with the actual original length, add a few bytes of random data, and then encrypt that whole thing, and we wouldn't even be able to know what the size of the original file was, other than it was a bit shorter than what we see. Yeah, that's an option. We're out of time. Any?
You mentioned that there's an API that you expose to
Yes.
third-party developers. So
Yes.
do you have any third-party developed apps that you endorse?
We have no third-party apps that we have endorsed. We have in-house developed apps from trusted developers that we do endorse, for example, our Android app. We see that there's quite a number of people using the SDK for third-party apps. We have even people who just reverse engineered the raw API, which is quite a feat, and offer their own implementations, not based on our own SDK. And we have not endorsed any of these, so you will not find any mention of those on our website. Use them at your own risk, just like you would run code in parallel to your browser using Mega or to the app using Mega at your own risk. Thank you.